Hello guys and girls. So today I would like to briefly talk about some caching fundamentals, just to bring us all on the same page when it comes to that topic. So to keep the long story short, because we are short on time actually. What is caching? So basically caching is saving something for later, to use it later. Maybe it's a calculation, maybe it's just a simple value. It doesn't matter. Probably what matters is why do we want to save that something. And there are a couple of reasons that we might want to do something like that. And one of the main reasons that we usually do that is because the something takes time to calculate, to generate, whatever, right? So that's one reason. Another reason is that whatever we do may cost money. So maybe you are using some API or some service that actually costs per call or per use. To get some results, and well, we might want to make some savings in this area. Next thing is obviously something what we can call resources, be it processing power. Maybe there is some quota on a service that we use, and we do not want to use it too much every time we call this service. Or maybe there is some throttling on some API endpoint, and we would like to leverage. We would like our code not to use too much of those API calls and therefore slow down the whole process due to throttling reasons, right? So, and maybe the last thing, last but not least, maybe there are other things, but also there's a concept of bandwidth. So if we need to transfer something over a network or over a different medium, obviously this takes time as well, and it can cost us something, right? So. When should we actually consider caching? Because if caching is so cool, or it makes things to be executed faster, or cheaper, or more effective, why not to use it everywhere? So I think that basically we should consider introducing caching when we have a problem. For instance, with user experience. And usually problems with user experience are related to the fact that something is just slow. If a user has to wait a couple of seconds for a result to be displayed, that's a problem. And maybe it's not a problem for admin that's using some admin interface and he just can wait. But if there are like hundreds or thousands of users that are waiting for some simple page to be displayed, then it might cause them to, maybe leave our site. And that's something that we don't want usually to happen. So another thing is obviously related to something that I have already mentioned, which are service costs. If we like to drive some costs down, be it for computing power or just something that we pay for directly, then maybe if there is such a problem, then we can address it with caching. Also, there are some things that are not per se related to user experience, but if we process somewhere in the background large amounts of data, sometimes in some places we can optimize the flow if there is a bottleneck with caching as well. So yeah, and obviously if introducing caching is relatively easy in given case, or especially if it is for free and out of the box in given solution, then why not to leverage it? But we need to be careful about that. So another question would be, okay, we got this cache, this something that we would like to store somewhere for future use, and where can we store it? So there are a couple of options here. All of them have some different trade-offs and advantages. First one is actually really simple. It can be a file. This file can be stored locally. It can be stored on web server, somewhere on in the cloud, wherever. For instance, if we have a report that needs to be generated once a day, then obviously we can store it somewhere on S3 or maybe locally on a server, and then provide it without generating it again. Usually storing in a file is useful for something that's, relatively big, right? So we don't want to save an integer in a file. That would be ineffective. Another place in which we could actually store something as a cache is a memory. This is by default enabled in Rails stack. However, there are some disadvantages to using just memory, because memory is obviously correlated with a process that is running this particular stuff we want to cache a value within. So for instance, if you have a Rails app, you will not be able to query cache within the Rails console. But this is actually not very relevant because, you use console just for debugging. But if you have a Rails app and a Sidekick process, if you cache something within an app, it won't be accessible in a Sidekick process. So memory is not shared, right? If you would like to share this kind of stuff, like payload of cache, you can use obviously some centralized caching solution like Memcached, and then if you are connected to the same Memcached server, as you probably should, then you can leverage it across many processes. So yeah, Memcached. Well, Memcached has some drawbacks. It's very simple solution, especially when it comes to ways you can work with it. Querying, selecting the keys you would like to expire, etc., and visibility of those keys. Well, this is kind of limited in this area. However, if you use Redis or maybe Postgres, maybe it's not the best idea to do that. However, in some cases it might seem reasonable. Then you do not have those problems. So if you would like to work with your cache in much more efficient manner when it comes to querying and working with it directly, then maybe Redis would be a tool of choice for you. Obviously, there is some store that's called null, and obviously it does not store anything. And usually it is very useful in development environment in which we don't want to mess up with cache because it may make our lives more difficult. So we know why we store, where we can store something, and now the next question is how, or maybe what are the types of caching that we can leverage in our applications. So here they come. First one is kind of, well, it's not very popular in our applications because our applications usually are authenticated, so there is not many pages that we can cache using page caching. But when we use page caching, what we do, we actually generate a page once and then we store it in a file that can be picked by a web server directly after that. So it doesn't even touch the Rails stack after it's cached once. Obviously, there is a problem because, well, it's not actually a problem, but it's a challenge because we need to somehow invalidate this cache, right? So we need to do it manually, be it by some separate process that deletes those files, or maybe by some callback in our code that will do the same. If we really need authentication or some other callbacks to happen before a given page is rendered or returned from server, we can use action caching. And action caching actually passes the request through action pack, but then it returns the actual payload or content of a page. And internally, it uses fragment caching from Rails. So it's just a fragment caching that is scoped around a host and a path. So basically, this is a cache key for action caching. Both page caching and action caching were extracted out of Rails, so they are available as separate gems. Because the now recommended way to cache parts of views or part of responses is fragment caching. Next thing is something called etag. Basically what etag is, well, maybe I'll describe how it works. When a response is generated, then there is some checksum, you can call it a checksum, but basically there is a string generated that is passed together with a request to the browser, and browser saves it for later use. And whenever it queries the same page again, it uses this etag and sends it back to server. And when the server actually generates this etag again, it can respond with not modified. 403, not modified? No. Oh, I don't necessarily remember the HTTP code, but basically it tells the browser that nothing has changed and the browser can use its local copy. So it's really simple to actually do it in Rails. You just use this tail method. This tail method will get all it needs from the resource that you would like to present in given scope. And if this product has changed in the meantime, between browser asked for it for a second time, then obviously we will render a response. If not, it will return appropriate HTTP status and will return no content. Next thing that's kind of usable in Rails is many times we are rendering collections of resources, and if we know that they are not changing that much, or we would like to improve performance in this area, we can use collection caching. It works really nice for pages representing just a collection of them. So it's really simple to implement it as well. Basically, you just add cached true to render partial with collection attribute, and it should work out of the box. Why not to use fragment caching for the same thing? Basically, when the collection caching is used, it queries cache for all the fragments at one time, so it's much more effective than calling cache each time for each fragment. But if there is just one fragment, like a module, like a block that you would like to cache for future use, you can use just fragment caching, and then it's, well, if it's not a collection, then this is your tool of choice. Obviously, there is something called rational caching, which means basically that you can cache fragments within fragments. The only thing that you need to remember here is that when a larger fragment is cached and its subfragment is cached as well, when the subfragment changes, it has to update the cache key for the parent fragment as well, because if it doesn't, then you'll get stale data on your page. So what you need to do, I know I have it here. Oh, basically, this is how fragment caching can be implemented from the view perspective. However, you need to add this touch true on the relations that bind those two resources together. Well, so basically, when the sub component is updated, the parent component is updated as well, so you don't serve the stale data. There is so-called SQL caching, which is delivered by default by Rails. So whenever within one request we query a database with the same query, results will be returned as they were from the first request. You don't have to do anything to enable that. I really wonder if we can disable that. I couldn't find information on this thing, but it's out of the box. If you just need to store some small value, and you would like to do it in some custom way, there's always low-level caching that is available in Rails, and it's as simple as calling Rails cache fetch and providing some cache key that will mark this particular value or tag it with a label. And you can also configure expiry of such value, so after those 12 hours it will be gone and will need to be regenerated. And for instance, there is some call to external API that might cost us or might take a long time to do it, so it might be worth caching. File caching, something that I have already mentioned initially. If you have a file generated, like a report, it's really good to consider storing it somewhere for future reference and not have to generate it again. And there something I called pre-calculations. For instance, counter cache. This is like caching in database. This particular example or this particular situation is related to when we have many objects in relation to other object, and we query a lot for the count of those objects that are related to their parent object. So then you can just cache this count in a column and query it directly without calling a bit more complex SQL query. So just an example of pre-calculations. And the last but not least, memoization is just caching the result of a method that was called within one request or within an object lifetime. So very useful technique. I usually do it every time I use that the method is used more than once. It actually calculates or queries something. It's just not simple read, for instance, from a const. And yeah, it doesn't have to change. Well, you don't need to track this change because it may happen during the object lifetime. Then I just memoize everything. And memoization is really simple. You just use this add access token with or equals operator, and then you just provide the value that should be calculated once, but not twice. Really, really, really simple. So there is this quote that everybody quotes when there is an article, speech, or anything related to caching, which is this quote. And I quote it again. There are only two hard things in computer science: cache invalidation and naming things. So I'm not really sure about that, but it's pretty adequate. Cache invalidation can be manual. You do it yourself, so you call the actual cache key and remove it manually or using some rake task, but you do it actually explicitly. So this is something that you probably don't want to do. You may have to, but this is prone to errors. If it fails, you can actually present stale data, and this is something that we don't want to happen. Key-based invalidation is something that's recommended by DHH himself. So basically, you build cache keys around some timestamp that's related to that basically represents information when given resource was updated. So then next time we query for given cache value, we use this timestamp as a cache key. So if it has updated, we'll generate it again. If it has not, we'll just use its previous value. And the last way to approach invalidation is just setting an expiry date. So if given, for instance, access token is valid for 1 hour, let's set this expiry time to 55 minutes. And for the duration of those 55 minutes, all this value will be fetched from cache. So as I said initially, there are not only advantages of using caching, there are some risks of introducing it, and those are too simple, but actually really important ones. So the first one is complexity with capital and underlined C, because it's very important. So in many examples, the strategy is really simple. We just cache one thing, but in real time and real projects, sometimes it's much more complex. And the more complex it is, the more complex it is to actually handle invalidation. And when you fail with invalidation, as I said, displaying stale data is not something that you would want to do, especially if you are running a web shop and you have increased your prices by some margin, and now all the customers are just buying the same stuff for the old price. So, for instance, or you are presenting some dashboard with some values, and your stakeholders say, "Oh God, we are in really bad shape," and you, "Oh, goddammit, okay, the latest revenue was not registered or not shown for you." So, yep, complexity grows well along the complexity of the solution itself. So be aware of that. And obviously, presenting the stale data is the ultimate risk of this problem. So initially, I have enlisted when we should consider using caching, and all those reasons were prefixed with problem with. If you have no problem, if everything works fine and nobody complains about UX, don't introduce caching. It just raises a chance that something will break sooner or later. Anything else? In Rails, caching is disabled by default, so you need to toggle it if you would like to test it. And there is a simple command that you can use to do that. It's bin rails dev cache, or there is a special file in TMP. It's called the dev testing txt. If you remove it, the cache will work. However, I do recommend just using this command to do the same thing. And last but not least, planning cache keys. Cache keys is something that identifies, cache key is something that identifies a given value from cache. If you do that right, if you actually plan the segments that will identify the particular resource, you can make the whole solution very flexible, and you will be able to expire your values very precisely in the future. For instance, you can expire cache for a user, for a company, for a domain, for a whole app separately in case you need that. So sometimes we don't care, but sometimes if it's more likely that you need such a functionality, take some extra time planning how your cache keys will look like, because, well, it actually has some value. Yeah, so if there are any questions, I would be glad to answer. That's great. Okay, thanks, guys.